Greetings, my young math Padawans. Here we are, chapter 7. We're going to talk about the area of the region between two curves. So, first of all, let's look at the general idea of it, right? We want to look and figure out what the area of this pink region is. And mathematically, that should make sense, because if we want to figure out what the area of this region is, we can look at the entire area underneath of curve F, and then subtract out the entire area under curve G. And when we do, we actually end up with the region between the two curves. So that integration is actually pretty easy when we know what the two curves are. And that's basically all we do with the integration, or to find the area between two curves, we integrate from A to B of the difference between the top curve minus the bottom curve. So remember that. That's really important, that we're integrating the boundaries, and it's always the top curve minus the bottom curve. And we want to do that. And it honestly doesn't matter whether we're integrating with respect to x or with respect to y. We can do the same exact thing with respect to y. Our bounds are going to be different, so maybe we'll go from C to D, and we'll do the right curve, the right minus the left curve, right? So the right curve, and again, that would be with respect to y instead of with respect to x. So again, the right would be the furthest from the y-axis minus the left curve, which would be the closest to the y-axis. It doesn't matter whether the curves are both above the x-axis or not. We're still going to do it exactly the same way. So here we are. We're going to find the area that is bounded by the graphs of y equals x squared. That's this red curve right here that you see, and y equals x. That is this line that you see right here. And of course, we have this region right here that we're looking for. We're looking for this green shaded region. Now, one of the things that I like to do is I actually like to draw in a little rectangle like you see here in the picture. I like to draw that rectangle in because it gives me an idea of what a little tiny cross section might look like, and it really helps me to see what the top curve minus the bottom curve is going to be. Okay, but we're just going to go ahead and figure out what this actually is. So let's set up the integral. So I'm going to say the area is equal to the integral, and I got to see where I'm going to start. Well, I look at the first x value, the lower bound. I'm going to go from -1, and I'm going to go all the way up here to 2. So my region is bounded from -1 to +2. And I'm going to do the top curve. Well, the top curve is the function x, and the bottom curve is x squared minus 2. So I'm going to integrate the difference between x minus x squared minus 2. And again, that's with respect to x. So I'll go ahead and do that math. So let's see here. The area is equal to the integral from -1 to 2. And I'm going to simplify it. That'll give me -x squared plus x, fix that, plus x plus 2 dx. All right, so now let's go ahead and integrate this. And let's see here, that will be -1/3 x to the third power plus 1/2 x squared plus 2x evaluated from -1 to 2. All right, so we'll go ahead and plug -2 and -1 into that, and I'm going to get this. And if I simplify that down correctly, I'm going to end up with a final answer of 9/2. All right, let's take a look at another one. All right, here is a little bit of a trickier one. So we have 3x to the third minus x squared minus 10x. That is this cubic function you see here. It's the red line. I know it changes green there in the middle, but it's that cubic function. And then -x squared plus 2. That's this quadratic function. And we want to take the top curve minus the bottom curve. We want to figure out what that green area is. Now, for this particular problem, we have to be really careful because we're going to have to break it up into several parts. Now, why? Because if you look here, this quadratic equation is below my cubic function until I get to 0. And then we do this little flip-flop, and then all of a sudden the quadratic equation is on the top. So we have to actually break this up into two separate integrals. So again, my area equals, my first integral is going to go from -2 to 0, and it's going to be the top curve minus the bottom curve. Well, the cubic function is the top here. Oops. Yeah, minus the bottom curve, which is that -x squared, the quadratic equation here. All right, that's the first function. And then we need to add the second one. We're going to add the second part of that integral. So that picks up and goes from 0 to 2. And here the quadratic equation is on top, that negative x squared plus 2x. And we're going to subtract the bottom curve, which is 3x to the third minus x squared minus 10x, the cubic function there. Again, we're going to integrate with respect to x in both of those problems. All right, now I'm going to simplify this, and if I simplify both of these expressions, I end up with this. And after I do my integration, I end up with this, which if I did the math and simplified that down correctly, I get 24 as the final area of that region. All right, let's take a look at one that's slightly different. Here we see the function x plus y squared equals 3. That is this sideways parabola that you see. And then x minus y equals 1. That's this linear expression. We want to figure out what the area between those two curves are going to be. And this is weird because I'm okay here, because here the line is above that quadratic until I get to 2. And then all of a sudden, the parabola is on top of itself. That one's really weird because what we have to actually do here is we'd have to solve both of these equations, get them in the form y equals. And if you know what would happen here with this first equation, you get a plus or minus if you tried to do that. That is just going to create a little bit of a problem for us. Now, not that you have to do it the way I'm about to show you, but an easier way to maybe do this problem is to take a look at it in terms of y. If we take a look at this and we look at it in respect to y instead of with respect to x, we can do a right curve, which again, now that's the parabola, minus the left curve, which is the line. So if I set it up this way, I'm going to integrate with respect to y, not with respect to x. But my area is going to be exactly the same. I can do it exactly the same way. I look at the lower bound of the two regions, and that's the y value of -2, right? The y value of -2, right down here. And I'm going to stop at the y value of +1. That stops right here. So I'm going to integrate from -2 to 1. Now I'm going to take a look at the right curve. I'm going to take the right curve, which if I solve that and get that in terms of x, that's 3 minus y squared. So I take the rightmost curve, 3 minus y squared, minus the left curve. Okay, again, I'm solving that for x, so I get x equals y plus 1. So minus 1 plus y. And I get that in terms of y dy. And I'm going to go ahead and simplify this. I'm going to distribute my negative and combine my like terms. Now I'm going to integrate this. And if I do the evaluation from -2 to 1 correctly, I get the answer of 9/2. I hope that this was helpful for you. And of course, here are your homework problems. If you have any questions, don't be afraid to ask. And I'll talk to you soon. Later.